Lesson 4.1 Water Cycle and Humidity. Good day, everyone. Today, I will be presenting a detailed report on moisture in the atmosphere, focusing on the water cycle and humidity. This topic is essential in understanding how water moves through the Earth system, how it influences weather patterns, and how humidity impacts our daily lives. So first, let's proceed to the topic of the water cycle. Water cycle, also known as the hydrological cycle, is a natural and continuous process in which water moves through different stages in the atmosphere and on Earth's surface. It is driven by two main forces, solar energy and gravity. Solar energy is the sun provides the heat needed for evaporation, while gravity pulls water downward, helping in precipitation and runoff. The water cycle consists of four primary stages: evaporation, condensation, precipitation, and collection. So first is the evaporation. Evaporation is the process by which liquid water changes into water vapor due to heat from the sun. This process occurs over large bodies of water such as oceans, lakes, and rivers, as well as from soil and plant surface, a process called transpiration. For example, after a rain shower, puddles on the ground gradually disappear as the water evaporates into the air. So second is the condensation. Condensation occurs when water vapor cools down and turns into tiny water droplets, forming clouds. As warm, moist air rises in the atmosphere, it encounters cooler temperatures, leading to condensation. For example, if you take a cold bottle outside on a warm day, you will notice water droplets forming on the surface. This is condensation in action. Third is the precipitation. Precipitation occurs when water droplets in clouds combine and become too heavy to stay in the air, falling back to earth in the form of rain, snow, sleet, or hail. The type of precipitation depends on the air temperature. For example, during a thunderstorm, heavy rain falls, replenishing the rivers and lakes. The fourth one is the collection. After precipitation, water follows two main paths: runoff and infiltration. So, runoff, water flows over land, collecting in rivers, lakes, and oceans. Infiltration, some water seeps into the ground, replenishing underground water sources. For example, rainwater that falls on mountains travels down into rivers, eventually reaching the ocean. So let's proceed to the topic of humidity. What is humidity? Humidity is the amount of water vapor present in the air. It varies depending on temperature, geographic location, and weather conditions. High humidity makes the air feel warmer, while low humidity creates a dry environment. Types of humidity: absolute humidity, relative humidity, and dew point. First is absolute humidity. Absolute humidity refers to the total mass of water vapor in a given volume of air and is measured in grams per cubic meter. For example, the Amazon rainforest has high absolute humidity due to constant evaporation. Second is relative humidity. Relative humidity is the percentage of moisture the air holds compared to its maximum capacity at a given temperature. For example, If the relative humidity is 80%, the air is nearly saturated, making it feel much warmer. A third is dew point. The dew point is the temperature at which air becomes fully saturated and condensation begins. Example: early morning dew forms on grass when the air temperature drops to the dew point. How humidity affects weather. High humidity and rainfall. High humidity leads to increased cloud formation and frequent precipitation. For example, tropical areas experience heavy rainfall due to excessive moisture in the air. Low humidity and dry conditions. Low humidity can cause dry weather, leading to droughts and wildfires. For example, is the Sahara Desert has extremely low humidity, making it one of the driest places on Earth. Humidity and human comfort. High humidity makes sweating less effective, making us feel warmer. Low humidity can lead to dry skin, chapped lips, and respiratory issues. Conclusion. To summarize the topic of Lesson 4.1, the water cycle is a continuous process that moves water through evaporation, condensation, precipitation, and collection. Humidity is the measure of water vapor in the air, influencing weather patterns and human comfort. Understanding this concept is essential for weather forecasting, climate studies, and water resource management. That concludes my report on moisture in the atmosphere, focusing the water cycle and humidity. Thank you for listening.
Good day, sir, and everyone. Before I start my report, can you see the clouds in the sky? What type of clouds do you see? Today, we tackle Chapter 4, Moisture in the Atmosphere, Lesson 4.2, which are all about cloud formation and types of clouds. On a sunny day, a wispy cloud can be a beautiful sight, but at other times, a cloud can be a sign of storm to come. How clouds are formed. Cloud formation occurs through convection. As the intensity of solar radiation increases, the warmer air becomes lighter and moves upward. As this happens, the temperature decreases. So does the amount of water vapors air can hold. Due to this, the process of condensation starts. These vapors rapidly condense and soon to clouds that composed of countless billions of tiny droplets or ice crystals. Clouds are occasionally produced by a reduction of pressure or by mixing a warmer and cooler air current. There are five factors that affect the cloud formation. First is temperature, humidity, air pressure, wind patterns, and geographic features like mountains and water bodies. First is temperature. Influences the ability of air to hold moisture. When warm air rises and cools, it reaches the dew point leading to condensation of cloud formation. Second is humidity. High humidity increases a likelihood of cloud formation since more water vapor is available for condensation. When air becomes saturated, excess moisture condenses into tiny water droplets or ice crystals forming into clouds. The third is air pressure. Low pressure system encourages rising air which cools and condenses to form clouds. Conversely, high pressure push air downward to prevent cloud formation and leading to clear skies. The fourth is the wind patterns. Winds transport moist or dry air, affecting cloud development. Converging winds force air upward, promoting cloud formation, while diverging wind can lead to clearer conditions. The last is the geographic features like Mountains and water bodies. Mountains force air to rise, cool, and condense, creating clouds, often leading to precipitation on the windward side, while water bodies contribute moisture to the atmosphere, increasing humidity and enhancing cloud formation. Meteorologists classify clouds mainly by their appearance. There are four major types of clouds based on their appearance: the cirrus, cumulus, stratus, and nimbus. Cirrus clouds, thin, wispy, feathery clouds that appear high in the sky and are made of entirely of ice crystals, and also a hair-like clouds. Found at a high altitude about 20,000 to 40,000 feet or 6,000 to 12,000 meters. Cumulus clouds are large, fluffy, puffy clouds varying in the color white to light gray. They are dense with observable round edges and flat bottoms. White fluffy clouds means no rain. Stratus clouds are low-level layers with a fairly uniform gray or white color. Flat, hazy, featureless clouds at low altitudes. Stratus clouds may produce a light drizzle or a small amount of snow or rain. The last is the nimbus clouds. It's also known as rain clouds. Dark gray clouds that produce rain or snow. Comes from Latin word means rain. It is a thick clouds and produce most precipitation. Meteorologists also classify special clouds like wall cloud, shelf cloud, mammatus, and fractus. Wall cloud is a large, localized, persistent, and often abrupt lowering of clouds that develops beneath the surrounding base of a cumulonimbus clouds and from which tornadoes sometimes form. Shelf cloud, a low horizontal cloud formation, usually be associated with a solid line of storms. The third is the mammatus, are condensed pockets of sinking air that look like cow udders lowering from the base of the clouds. Mammatus clouds can be eye-catching, especially at sunset. The last is the fructus. It is also called fructus stratus and fructocumulus, are small, rugged cloud fragments that are usually found under an ambient cloud base. Clouds are the key factors influencing local weather as well as the Earth's climate system. They affect the overall temperature of energy balance of the Earth and play a large role in controlling the planet's long-term climate. We need accurate data on the clouds to understand their impact over time.
Good day, everyone. Today, I will be discussing an essential topic in meteorology, which is precipitation. This lesson will cover the different types of precipitation, how they form, and their significance in weather patterns and climate. So let's get started. What is precipitation? Precipitation refers to any form of water, maybe it liquid or solid, that falls from clouds and reaches the ground. It is a crucial part of the water cycle and plays a significant role in maintaining Earth's water balance. Without precipitation, life on Earth would not be sustainable. Let's talk about the formation of precipitation. Precipitation forms when water vapor in the atmosphere condenses into water droplets or ice crystals. When these droplets or crystals grow large enough, gravity pulls them down as precipitation. Factors such as temperature and humidity determine whether precipitation falls as rain, snow, hail, or sleet. There are three main types of precipitation. First is the cyclonic or frontal precipitation. This occurs when warm air and cold air masses meet in a low pressure system. The warm air is forced to rise, cool, and condense, leading to precipitation. Second is the convective precipitation. This happens in warm conditions, when air that is warmer than its surroundings rises, cools, and condenses. It often results in thunderstorms and heavy rain showers. Third is the orographic precipitation. When air masses are forced to ascend over mountains, they cool and condense, producing precipitation on the windward side of the mountain. So the first type of precipitation is rain. Rain is the most common type of precipitation. It occurs when water droplets and clouds merge and become heavy enough to fall. Rain provides fresh water essential for drinking, agriculture, and ecosystems. It also helps regulate temperature by cooling the surface of the ground. The other type of precipitation is snow. Snow occurs when water vapor freezes directly into ice crystals without passing through a liquid stage. It typically forms in cold temperatures. Snow is vital for regions that depend on snowmelt for their water supply, and it also affects transportation and daily life during winter. We also have hail. Hail consists of ice pellets that form in strong thunderstorms. These pellets grow as they are carried up and down in storm clouds, collecting more layers of ice. Hail can cause significant damage to crops, vehicles, and buildings, making it one of the most destructive type of precipitation. Sleet occurs when raindrops pass through a layer of freezing air before reaching the ground. This causes them to freeze into small ice pellets. Sleet differs from snow because it starts as rain before freezing, while snow forms directly as ice crystals. Sleet is uncommon in the Philippines because our climate lacks the necessary cold air layers. However, in temperate regions, sleet can create hazardous conditions by making roads slippery and dangerous for travel. To better understand the differences among these precipitation types, let's compare their characteristics. Rain is liquid and the most common form. Snow consists of ice crystals, and hail is large ice balls formed in thunderstorms. The presence of different temperature layers in the atmosphere determines which type of precipitation will occur. This comparison helps us appreciate the complexity of weather patterns and their effects on different regions. The importance of precipitation. Precipitation is essential for sustaining life. It replenishes water bodies, supports agriculture, and influences climate patterns. However, too much or too little precipitation can lead to natural disasters such as floods and droughts. Understanding precipitation helps us to predict and prepare for extreme weather conditions. Precipitation in the Philippines. In the Philippines, precipitation is primarily in the form of rain, due to the country's tropical and proximity to the Pacific Ocean. Typhoons and monsoons bring heavy rainfall, often leading to floods and landslides. Hail is rare, but it has been reported in high altitude areas, such as in Benguet. Snow never falls in the Philippines because of its consistently warm temperatures, and sleet is also uncommon due to the absence of cold air layers needed for its formation. Now let's talk about an important figure in meteorology, Luke Howard. Born in 1772, he was not only a chemist but also amateur meteorologist with a deep passion for studying clouds and weather. One of his greatest contributions was developing the nomenclature system of cloud, which he presented in 1802 to the Ascetian Society. His classifications of clouds, such as cumulus, stratus, and cirrus, is still used today, making him widely known as the father of meteorology. He also called as the namer of the clouds, and even the godfather of the clouds. His work helped lay the foundation for modern meteorology, allowing scientists to better understand and predict weather patterns. So, all in all, precipitation comes in different forms, like rain, snow, hail, and sleet, each with unique characteristics and impacts. By studying precipitation, we gain a deeper understanding of weather and climate, which is crucial for making informed decisions, agriculture, urban planning, and disaster management. Thank you for listening, and I hope you learned something valuable today.